This recording covers Chapter 17 on nutrition, fitness, and health. Another way to look at this chapter is on the chemistry of wellness. The world has changed a lot since early human history. There, the main concern was really eating enough food to stay alive. Now, in general, the focus is on what kinds of food people are eating because there's so much food available. And in addition to that, people in general are not getting the types of exercise that they need. Starting off with a calorie. Calorie is a unit of energy, and it's widely believed that caloric reduction may be the key to long life. In mouse studies, caloric reduction has demonstrated to promote longevity, and humans tend to stay healthier when they eat less overall. If we look at the average caloric intake per capita, and this is back in 2003, you can see that the United States was averaging around 3,754 calories per day. That's in direct contrast to the recommended caloric intake a day for an adult female is around 2,000 and for an adult male is around 2,500. That's also in comparison to other countries like China, where the average caloric intake would be 2,940. Also, some interesting numbers. Michael Phelps, when he was at the height of his Olympic career, he was consuming about 12,000 calories per day. Sumo wrestlers can consume as much as 20,000 calories per day. So there is a general recommendation on how many calories people should consume, but there are other factors that come into play, especially activity levels. The USDA has some guidelines set in place as far as the types of foods and the amounts of foods that people are eating based on that 2,000 calories per day. Although, like I said before, it needs to be tailored to the individual, and it is dependent on things like age, sex, activity level, and also general health. As part of that recommended daily intake, it is recommended that the total fat intake is around 20 to 35% or less of your calories per day. For American diets, more than half the fats are animal fats, and 70% of saturated fat comes from animal products. And if you remember from the last lecture, we talked about those saturated fats and how those can lead to increased bad cholesterol levels, which can lead to some things like arteriosclerosis. As I said before, it's recommended somewhere between 20 to 35% of the total caloric intake comes from fats. Most of those should be polyunsaturated fats. Less than 10% of them should be saturated fats, and trans fats should be limited as much as possible. Also, just as a reminder, calories from fats that are those unsaturated fats, those are considered the good fats: fish, broccoli, nuts, fruits, versus the saturated fats, butter, cheese, egg, animal product fats. The other macronutrients, other than the fat recommendation, is that the calories that come from protein should make about 10 to 35% of your daily calories, and the calories that come from carbohydrates should be about 45 to 65% of the daily calories. And in general, it's important to understand also that athletes tend to need more calories, and their individual breakdowns will depend on their ultimate body composition goals. Other than those macronutrients, which are fats, proteins, and carbohydrates, there are other nutrients that are essential to human health. These include vitamins and minerals. Vitamins are substances that the human body needs but can't manufacture itself, and we'll talk more about those in a second. And then also minerals. These are inorganic elements that are also required by the body. Many medical professionals say that vitamin supplements are unnecessary as long as you have a balanced diet. But if you take them reasonably, they aren't likely to cause any harm. Starting with minerals, minerals are, like I said, those inorganic substances that are natural for life. Bulk structural elements and macrominerals make about 99% of all the atoms in the human body. Another way to say that sentence is that these minerals that I'm talking about are very important to the basic structure of the human body. And if you have a deficit in those, it can lead to some serious consequences. So lack of dietary minerals really does have serious consequences. Like in this picture here, lack of iodine in the diet can lead to thyroid goiters. And one of the ways that we increase iodine in the diet is a lot of places iodine is added to table salt. This table here just lists some of those minerals that I was mentioning before that are important for the overall structure of the human body. Vitamins are organic compounds that are essential in the diet. They don't include those macronutrients and minerals, so they don't include proteins, fats, carbohydrates, or minerals. They are the other things that people need in their diet. And there's two general classifications of vitamins. There's fat-soluble and there's water-soluble. If we're talking about water-soluble vitamins, these are the vitamins that can be absorbed directly into the bloodstream. So you consume them and they can be absorbed directly into the bloodstream. And because they can travel in the blood, they can travel all throughout the body easily. But because they are water-soluble, they can't be stored in the body long-term. They are excreted through the kidneys relatively quickly. If we're talking about toxicity as it relates to the water-soluble vitamins, it is possible to reach toxic levels if you consume a large amount of the water-soluble vitamins at one time, but because they are excreted so quickly, they don't tend to reach those toxic levels as easily. Also, because they are excreted so quickly, they are needed much more frequently. So in general, it's recommended that those water-soluble vitamins are consumed every 1 to 3 days. That's in contrast to fat-soluble vitamins. Fat-soluble vitamins, these need ways to get into the blood and to be transported around. Because they are fat-soluble, it allows them to be stored in fat tissue. So that makes it more difficult for the body to excrete them because they can be stored relatively easily. And because they can be stored in the body easily, it's easier to reach those toxic levels from consuming too many supplements. Because they are able to be stored in the body, you don't need them as often, so you just need to take them periodically. There is a list here in your textbook of various different vitamins, and I'm just going to hit a couple of the key ones here. Before I do that, though, I want to mention a couple of things. There are a lot of different vitamins, and they come from a lot of different natural food sources. And as you can see in this graphic, these different vitamins play crucial roles all over the body. Without the proper amounts of vitamins, you can have some serious consequences. So vitamin deficiency, getting a lack of particular vitamins, and this becomes more important during specific developmental times. But you can see in the top picture there, that's softened bones due to vitamin D deficiency. And then in the bottom picture, a skin condition due to a niacin deficiency. So there are vitamin deficiencies that can lead to serious consequences. Let's talk about a couple of the vitamins now. Vitamin A is a fat-soluble vitamin that's very important for vision, bone development, and skin maintenance, and has also been suggested that it could be help to resist against certain types of cancers. Most vegetables like broccoli and cauliflower, Brussels sprouts, cabbage, those contain beta-carotene, which the body will convert into vitamin A. B vitamins are a whole series of vitamins. They are water-soluble vitamins that are important in the skin and nervous system. They include things like vitamin B3, which is that niacin that I mentioned before. That's been shown to lower blood cholesterol and help with arthritis. Vitamin B6, another one that's been shown to be helpful with arthritis. Vitamin B12 has been shown to prevent against certain types of anemia. And folic acid is another B vitamin that's crucial in the development of the nervous system to a fetus, and it also has been shown to help prevent cardiovascular disease. Vitamin C is also known as ascorbic acid. It's a water-soluble vitamin and it serves a number of functions. It can help prevent scurvy and promote the healing of wounds, burns, and lesions. It's important in maintaining collagen and is an antioxidant. Additionally, it's been shown to increase the body's production of something called interferons, which can help interfere with the growth of viruses. Vitamin D is a steroid-type hormone that helps to promote the absorption of calcium and phosphorus to maintain healthy bones and also prevent rickets. Most mammals will produce enough of the vitamin D as long as they are exposed to sunlight. Finally, you have vitamin E. Vitamin E is an antioxidant. It helps deactivate something called free radicals. Free radicals are things that are shown to cause cell damage within the body. It's been used to treat coronary heart disease, high blood pressure, varicose veins, and other cardiovascular problems. So that was in no means all of the vitamins, but those are kind of the main vitamins. Other things that are essential for diet include things like dietary fiber. Fiber can either be soluble or insoluble fiber. Insoluble fiber is things like cellulose. That would be stuff that cannot be dissolved into water. Soluble fiber would be things like gums and pectins. Fiber in general is essentially just something that your body doesn't absorb itself, but will pass through your digestive system nonetheless. It's been shown to have a number of health benefits. It can help maintain proper colon function. It can help control blood sugar because it actually decreases the amount of sugar that the blood is absorbing from the diet. And it can help to lower cholesterol levels. Water is another essential component to nutrition. Most of what we ingest is actually made up of water, but in addition to that, it's generally recommended that you get about 1 to 1.5 liters of water a day. Water does a whole lot in your body. It helps to cushion your joints. It helps to remove waste. But a big one that often I think gets overlooked when it comes to water is the regulation of body temperature. So if you're one of those people that tends to feel cold all the time, one possibility could be that you're just not consuming enough water, so your body is having a hard time regulating that body temperature. When we talk about water, electrolytes is often something that is associated with that. Electrolytes are substances that form ions in solution and help to conduct electricity. In the human body, electrolytes are really important because it helps cells maintain charged balance and controls the flow of water molecules across the cell membrane. Electrolytes include things like sodium, potassium, chloride, calcium, magnesium, etc. And you do tend to lose electrolytes when you sweat. There are some ways to replace those electrolytes, including like eating a banana or eating some nuts. Those are good ways to replace electrolytes that don't include also consuming large amounts of sugar like you would if you were drinking something like Gatorade. In general, the best way to replace lost water through sweat, tears, respiration, whatever, is to actually drink water. If you don't drink enough water, you can become dehydrated. In general, you can know you're drinking enough water by looking at the color of your urine. We become thirsty, so we start to feel thirsty when our blood volume decreases by about 1%. So as soon as your blood volume goes down by about 1%, that's when your brain triggers your body to feel thirsty. After that, the conditions of dehydration get worse. You can have muscle cramps, dizziness, brain cells that shrink. For example, at about 4% of body weight lost is sweat. That's when your muscular work capacity starts to decline. At about 5%, that's heat exhaustion. 7% is hallucinations. And once around 10% of your body weight is lost to sweat, that's when you have that circulatory collapse and heat stroke. Circling back to that 7% hallucinations, the reason why you hallucinate when you're dehydrated is because the cells in your brain are shrinking, which can cause confusion. If we're talking about nutrition and food, one last thing to sort of enter in there is the idea of food additives. Food additives are substances other than basic foodstuffs that are put into food as a result of things like processing, production, packaging, or storage. The main food additives are sugar, salt, corn syrup, citric acid, baking soda, vegetable colors, pepper. Those are about 98% of all the additives by weight. You can see there's a lot of different types of additives. So you can have preservatives. Those are probably one of the more important ones. Those are antimicrobial, so they'll help prevent bacteria from growing on the food. Nutritional supplements, that's adding vitamins and minerals. So oftentimes vitamin D is added to milk. As I mentioned before, that iodine added to salt. You can have flavoring agents, so those are that sugar, corn syrup to make things taste better. Color to change colorings will do what they say, they change the color of food. Texturizing agents, so things to make things feel smoother. And then there are others as well. If we're talking about food additives, they're likely a necessary part of society. Every year there's about 76 million illnesses in the United States, including about 5,000 deaths due to bacteria, viruses, and other parasites that grow on food. And a lot of time, the use of various additives, specifically preservatives, can help to prevent that. I'll look at some of the additives that help to improve nutrition. As I mentioned before, adding iodine to salt to prevent goiter. Vitamin B1 is typically added to rice. Vitamin C is typically added to juice. As I mentioned, vitamin D added to milk. And then vitamin A a lot of times is added to margarine as well. So these are specific additives in order to improve the nutrition of food. There are also additives that are used to improve the flavor of food. One of those is MSG. If you consume too much MSG, it's been shown to cause birth defects and is generally not recommended for pregnant women. And then you have those additives that are used to prevent spoilage. So those are antimicrobials to prevent things like mold, yeast, or bacteria. Sodium nitrate is often used to cure meats. It gives the pink color to ham, hot dogs, bacon. However, stomach acid has been shown to convert that nitrite ion into something called nitrous acid, which can then react with other things in the body to form some known carcinogens. So there is some concern about the specific addition of things of nitrates to food, which is why you'll see some of those cured meats now advertising that they have no nitrates added. Starvation is the total deprivation of food. It takes less than 1 day for the body to deplete itself of those glycogen stores that we talked about last chapter. Once that glycogen is depleted, the body will metabolize the fat reserves, and that leads to something called ketosis. Ketone bodies are then released into the blood and urine, which can, if done unchecked, lead to something called acidosis as the blood pH drops. Body proteins will also be metabolized during this point, and eventually muscle proteins will be metabolized as well. Malnutrition refers to deficiencies, excess, or imbalances in a person's intake of energy and or nutrients. So malnutrition isn't just not eating enough food. It can be eating too much food or not eating the right types of food. A lot of times malnutrition can occur as a result of eating too much processed food. Processing food will remove a lot of the nutritional value and fiber. Another is undernutrition, which includes stunting weight, wasting, underweight, and other micronutrient deficiencies or insufficiencies. The other type of malnutrition then is overweight. Obesity and diet-related diseases are related to that, things like heart disease, stroke, diabetes, and cancer. Weight loss diets are very popular. Dieting is a major industry in the United States. And it's been shown that if you are able to reduce your daily caloric intake by about 100 calories a day, you can lose 1 pound of fat in 35 days. One issue with these low-calorie diets, though, is that they are very likely to be deficient in proper nutrition. A quick overview on how hunger works. So hunger is not an easy thing. There are a lot of different compounds and chemicals in the body that play a role in hunger, but we'll just talk about a couple. The first one is ghrelin. Ghrelin is an appetite stimulant. It's produced in the stomach, and from there it goes up to the brain to tell the brain that you're hungry. Peptide YY, or PYY, is an appetite suppressant that's produced in the gut. It then travels through a large series of different places before ultimately getting to the brain to say that you're full. Leptin is a protein that's produced in fat cells. It helps to promote weight loss by decreasing appetite. Leptin is also produced in the stomach. And one of the things that's interesting about leptin is that many obese humans seem to have very high blood levels of leptin, but are resistant to its effects because ultimately Leptin is supposed to decrease appetite. CCK is a peptide that's produced in the intestine, and it also signals when you've had enough to eat. So as I've mentioned, the biochemistry of hunger is pretty complicated, and I just was hitting some of the four examples of compounds that are used to play a role in hunger. Another way to lose weight is through exercise. Exercising increases your metabolic rate. Your metabolic rate is just basically how quickly your body burns through calories. If we're talking about metabolism in general, about some of your metabolism is just your everyday activities, so breathing, digesting food, the things that your body is doing regularly. That's called your basal metabolic rate. Then you can increase that metabolic rate a little bit through exercise, and then some of it also plays a role in just regulating your body temperature. One of the things that, just to mention, is a difference between males and females, so that males tend to have a higher resting metabolism, which means they're burning more calories just by their body doing everyday normal processes than women do, which is why men are recommended to consume more calories than women. We're talking about fitness. Fitness is usually measured by the amount of body fat. There's a few different ways to determine the amount of body fat. You can look at a person's density, which is probably the best way, so doing one of those dunk tank analyses. But you can also look at measurements of waist and hips, or by performing a bioelectric impedance analysis. Bioelectric impedance analysis, if you've ever done it, is when you basically take an electrode in both hands, and it passes an electrical signal from one to the other, and it measures essentially how long does it take that signal to go through. So if there's more fat, it's going to take longer. That was it's not exactly how that works, but it's a basic overview. Another way that is typically, or number that's typically used to talk about fitness, is body mass index, or BMI. If you're especially lean or you're a bodybuilder, you may weigh more from your height than usual, and that's typically because muscle tissue is somewhat denser than fat. So the BMI computation will show you as falling into a range of overweight or even obese. However, you don't have an unhealthy body fat composition, and probably not at an increased rate to chronic disease or other unhealthy weights. So in most cases, it should be obvious to your doctor and you that BMI categorization is inappropriate if you're muscular and fit. VO2 max is probably one of the better measures of fitness. It's the maximum amount of oxygen that a person can use in 1 minute per kilogram of body weight. It can also be estimated from maximum heart rate. If you look at elite level athletes, their VO2 max is typically twice as the average human, so they're able to use oxygen much more efficiently. The American Heart Association calls VO2 max the important overall correlate to health and the strongest predictor of cardiovascular disease. So very low VO2 max would put you at high risk for heart failures. If we're talking about nutrition in the athlete, just a real quick statement we're going to talk a little bit about muscular chemistry. So it's important to remember that we get energy from carbohydrates. A lot of times people come with the assumption that by consuming more protein they can build more muscle, but muscle itself is built through exercise, not through consuming protein. So as your muscle contracts against resistance, the amino acid creatine is released, and creatine actually stimulates the production of a protein called myosin. And myosin contributes to the construction of muscle tissue. So if we're looking at a blow up here of the muscle, the point from this image is just to understand that the muscle itself, that muscle tissue, comes from the production of the protein myosin, and that comes from the muscle contracting against resistance, which is something that would happen during exercise. A little bit more about muscles itself. The human body has about 600 muscles. Exercise makes the muscles larger, more flexible, and more efficient in their use of oxygen. with regular exercise, a person's blood pressure and pulse actually tend to stay lower, and they're able to do more physical work with less strain, and that's called the training effect. So you can look at this study here. They had a group of individuals. They put one group in something called the training group and one group in the control group. And you can see at the beginning of the study, they had an average blood pressure of around 100. And then they took those two groups, and the training group trained regularly and the control group didn't. And you can see the training group had a pretty significant decrease in their average blood pressure than compared to the control group. A little bit more on muscles. Two proteins play a really important role in the contraction of a muscle, and those are called actin and myosin. Together they form a complex called actomyosin, and they need a molecule called adenosine triphosphate, or ATP, in order for the muscles to contract. So the body will consume glucose through the diet. It consumes glucose by eating carbohydrates. The body will then convert that glucose into ATP, and that ATP molecule is crucial in order for the muscles to contract. And those two proteins that I mentioned, the actin and myosin proteins, they essentially walk along each other, either contracting or relaxing the muscle. During exercise, ATP in the muscle is consumed very quickly in a matter of minutes. The muscle then will accumulate glycogen and store it for energy. Under aerobic conditions, when there's enough oxygen present, the glycogen is converted into something called pyruvic acid, which is then quickly converted into carbon dioxide and water. So under aerobic conditions, the body can maintain that movement. Anaerobic exercise and oxygen debt, what happens is that pyruvic acid is converted into something called lactic acid, and then the lactic acid is not broken down into carbon dioxide and water. It's not broken down at all, and it accumulates in the muscle, leading to pain and muscle fatigue. Finally, the last thing to mention is that there are two different types of muscle fibers. There are slow twitch type 1 muscle fibers and fast twitch type 2 muscle fibers. Type 1, or the slow twitch fibers, have high myoglobin levels, which basically means they have high respiratory capacity. They have more access to oxygen. They're used for light or moderate work and are acted under aerobic conditions when you have that oxygen around. The fast twitch muscle fibers have a high level of glycogen use, and they can use ATP relatively rapidly. They're stronger muscle fibers that are better suited for anaerobic activity. In general, it's said that marathon runners, they're going to be using their slow twitch muscle fibers, whereas sprinters, sorry, that's my dog, are going to be using fast twitch muscle fibers. In endurance exercise, as I mentioned before, the marathon runner, they're going to have high levels of those type 1 muscle fibers. Weight training, those are going to have high levels of those type 2 muscle fibers. What's interesting about muscle fibers, though, is that the muscle fiber type seems to be inherited. So let's say you come from a family of bodybuilders, weightlifters, but you want to be an endurance marathon elite level athlete. That may be difficult because if you have a lot of weight trainers in your family, they probably have a high level of those type 2 muscle fibers, which means you probably do as well. World-class marathoners, if we look at their muscle fiber distribution, about 80 to 90% of those fibers are slow twitch. Whereas if we compare that to sprinters, about 70% of their muscle fibers are fast twitch. That will conclude chapter 17.